Hey, let's continue. I just got confused with radar notation of that challenge. So challenge 1, and then we just disassemble that here. Okay, here it's comparing. Once we put everything, we get that and put it here, and then we compare. This is our actually flag, but we'll see now. Then push that and compare them. Okay, so let's just do that. Break here and run, and then we'll just give some A's. It doesn't matter here, we just try to get the content of both. Okay, now breakpoint, we need to get this x this is a password actually, and it's being compared by our input, which is some A's, which would be wrong. So now we just need to run again and enter that password to print the flag. Should be very straightforward. Continue. Flag is iHack 2018, easy one. So this is the flag. We can go out here and echo flags, reverse engineering, flag 1. Okay, now let's clear that and exit of radar and go to the next challenge. Reverse, another password challenge. Reverse engineer binary to get the flag. Let's try to use the same approach and see if it's going to work or not. So cp shall to actually that one. Here as chal1, chal2, ls, yes, Hashim plus x, chal2. Yeah, let's try to execute that as well. Chal2 password, no flag review. Okay, let's just go straightforward to gdb and see if we can solve it only with gdb without understanding the whole visual notation. Okay, set this is simply until okay, now we can now it's calling something here, betrays bots. and it's asking for there's something that is being put here, and then it's being concatenated with string cat, and then there's another thing and being concatenated. Now this is like the enter the password string, and here scanning and checking if string len is get this string len, checking if string len is f, which is 15. Okay, and then jump equal to here. String compare this and this. So let's just try to use the same approach. Just break this and run. Yeah, of course the protection here, the protection used here is there is a protection that the binary has. It's in the next challenge, so let's leave it to the next challenge, so that we can't set breakpoints here. But let's open that in radar and see what we can conclude of it. Two. There is string concatenating going on, so let's just open radar and see if we can get that in clear text. And okay, first call that, and this is actually the protection, and it goes to no if there is any like reversing or debugging attempts going on. So now flag the strings are hack foot star something here, which is actually 0. Here string cat, we getting this. Keyword s2 with s1. Yeah, we know that s2 is hack foot, and we got s. Here, let's see, we got this is for 74. So they are being concatenated here, s2 with s1. So yep, so it gets the password, checks string len, ex f. Okay, password is too long. If it's longer than 15, it will be too long. If it's 15 or less, it will go here and string compare s1 with s, which is, let's see here, with s that has been scanned with scanf is pushed here, and here this is the format. Okay, and then they're being compared together. So let's try, just delete that, delete one and run. Okay, let's just go out and share 2. Let's try just to enter those. Nope, no, that one. Spoiler alert. Yep, that one. Let's get that. Hackfoot star with S and capital, with capital S and R. This star, maybe that, just try. Yes, the flag is Hackfoot star. Actually, it's also printing something here, but this is actually the flag, and we can just do, oops, echo flag to flags. Okay, now the next challenge has been solved. Just go here, out, here. Let's go for the third challenge, which is what is the protection used by challenge 2. Okay, before we close that, we should have looked at the protection. Actually, the protection is here. There is a debugging protection using ptrace. This is the, see the challenge saying just submit the API call for the protection, example block RE. This one is similar one, it's ptrace. So this is just the flag, just ptrace. So echo flag 3 ptrace. Yes, it's that simple. Number 4, keygen for your flag. This is actually a bit confusing one, so let's just go ahead and download that. CB 3 Okay, let's try to execute that. Actually, we need to change mode it first, so that we can actually execute it. 3 key, give me key, not correct. Okay, first just need to open that, and let's open that in GDB and try an error maybe. Okay, let's look at radar first. Maybe it's easier here. 3. Let's go VV, and we have main here, we have succeed, we have fail, and we have generate random. Generate random is actually the flag generator, we don't need to revert that. And there is check with mod. This is actually a bit confusing if you are starting with reverse engineering like I am. Let's go here. Okay, now it's taking, just printing those. And getting this trillion and comparing that with 16. This is the hex for 16. So now, yeah, it's putting in AX, and then it's putting in that variable local 20 edge, and then it's comparing it with 16. If it's equal 16, it will continue to the actual code here. If it's not 16, it will go to fail. Now it's going here and it's checking something. For being B, and if it's not B, it will go to fail. So let's just break here and see where is that B exactly. Let's just go here. Coordinates. Here, let's break here. And then get the that one. Okay, so let's be run. Let's just enter a pattern. Okay, E B C D E F G H I J K L M N O P. Those are 16, so that we pass the check that checks that it's actually 16 character. So now we'll hit the breakpoint, and then we need to see. We can see it actually on the stack. Yeah, this is our input. We need to check that here. Let's examine that as a string. See, here it's printing C at the beginning, so we know that we entered ABC, so it's checking if the third character is actually 42 in hex, which is B. So if I now continue it, it's just going to go out because it's not B. So let's see if there is another check here. After this one succeeds, it goes here and checks for another variable or for another location that it holds Q 51 in hex, and if it's Q, it will go it will succeed. If it's not, it will fail. So let's do the same thing again and go to gdb. Let's break here. Yes, let's break here. This is our second breakpoint. Okay. Okay, now we have two breakpoints. One before checking for B and one before checking for Q. So if we pass the B check, then that means that we're actually on the right way here, or on the right path. So let's just run A, B, B, D, E, F, G, H, I, J, K, L, M, N, O, B. Okay, now I put the third character is B instead of C, so that I can check if I will actually pass that check or not. So now I hit the first breakpoint. Let's continue and check if we hit the other breakpoint or not. If we hit it, then we're doing okay and we can continue. Yes, we do hit it. So we go here and grab that. I'm grabbing that because actually it takes this byte from this, one byte, and put it in AX, and then checks and extend all with zeros, and then checks if the AL is 51. That's why I'm getting it from here. Okay, now let's examine that as a string. Nope, which is the third last character needs to be Q. So let's continue. It just goes out, and then let's see in radar what else. So we now know that the third character should be B, the third last character should be Q. Now there is apparently another check here. It's pushing arguments for some function. It's pushing 3 and pushing 4 and pushing AAX, which is actually our input. Yes. So now it is going to this function. So we need to know what this function does. So let's just go out here, just VV again, and go to this function. Okay, now this function do what? Goes here, compulsory jump, and then it goes here. There is some kind of a loop apparently. Okay, goes here and checks. First it zeroed out two variables. Now it's going to load those variable here to AX and compare AX with argument character and jump if less. So it's probably checking if it's less or not. If it's less, it goes here. If it's not, it goes here probably. So now there is something that we can notice here, that it actually goes just here. So, and this is incremented by 1, so this is a for loop apparently, and this is added to EAX every time. So I'll I'm just going to assume that it's iterating through the input, and every time it's adding the value of that character to a local variable, and then when the for loop ends, it goes here, and then it does that, which I'm not sure what it is, and then it divides. So the EAX holds the actual division result, and EDX holds the remainder, and then it tests if the EDX, which is the remainder, it puts it in AAX, and then it tests AAX if it's 0 or not. Okay, then it puts AL here, so we need it to be actually 0. We need it to be actually 0, because set if equal, so it will set AL to 1 if 0. So that function basically returns 1 if the result, or the result of the addition in that loop resulted in a number that is divisible by what? Dividable by this, which is an argument that has been pushed to that function earlier in the main. So let's see. To figure that out, we need to debug a little bit. So let's go here, and yes, let's just this simple check mode. If it's less than this, goes to here. So now we need to know what is it exactly checking. So let's check here. Yes, and check AAX every time. Let's break here. Let's try. Okay, now let's run A B B D E F G H I J K L M N and O B. Instead of N, we're going to put Q to bypass the second breakpoint, and then let's just do that. So continue. We hit the next breakpoint. Now let's see what is AAX, because here it's actually comparing with AAX. Here in the for loop, it's comparing with yeah, it's adding AAX. It's adding AAX here, adding AAX. What is AAX? AAX is just 0 for 1. Now let's see what is the for loop limit, or what is the counter limit. Let's see here. It's here. What is the counter limit? It's checking if this one is less than this. This. So examine that. It's 4. So it checks for. It is starting from the beginning, and it checks until 4. So it checks the first 4. Okay. Let's just continue. I'm going to assume that it's going to add this and this and this and this. The 4 first character. let's go to continue. We hit again. If we check the same, the counter is still 4. The limit of the counter is still 4, of course. But if we check this, oops. What did I check last time? Yeah, I checked the AAX. Yeah, here the AAX is what? Is B. Now is B. Continue. Now is B, the other B. Continue. Now is D. Now is D. Okay. Now if we continue, we will go out of this function. How do we know? Let's put a breakpoint here to make sure that we're going out of this function. Breakpoint. This is breakpoint 5. Let's continue. We hit that breakpoint 5, so we're going out. But if we continued, it will just fail. Why? Because because if we see here in radar, it's doing some check. Here it's dividing by something, which actually it would have been better if we checked what that something is. It's actually the argument that has been passed to it in the main, which is that one, 3, and this is the fixed number is actually the limit of the for loop. So this is 3, and then if it failed, if it's divisible by 3, then it will succeed. Then it will push again, but this time 4, and if it's divisible by 4, it will succeed, and this time it will push again and call the function again, and if this time by 5, it's divided by 5, it will succeed, and then 4, it will succeed, and it will all succeed and print the flag and go generate a flag for us. Okay, so now we need to know, so in every time it's taking 4 characters. Let's just confirm that. Okay, let's just confirm that. What do we need for the first one? To be divisible by 4 and to be let's just open a new window here. Python hex of x4 1. This is 0x. Yes, 0x for 2, 0x for 2, 0x for 4. 109. Is it divisible by 4? Let's see. By 3 actually. This is the first check is 3. So 3. Let's get the remainder instead of the division. 1. So it failed. The first check failed. Okay. So let's just keep that. We have to keep that because this is A, this was B, this is B, this is D. We need to keep that B, and we can just keep that A instead of B. Now it's 0. Let's see if we actually pass this check if we entered A, B, D as first 4 characters. Okay, run A, B, D, and let's just continue with A, B, D, E, F, G, H, I, J, K, L, M, Q, O, B. Okay, and let's see if we'll hit. We know that breakpoint 3 is inside the mod function. Let's check with mod function. Let's see if we hit it again. This is the first breakpoint, continue. This is the Q check, continue. This is the one inside that mod function. Check with mod function here. Let's continue. We'll hit it 4 times. This is the second, third, the fourth, and now we'll hit the return, which is breakpoint 5. Now if we bypass the check of that 4 characters divisible by 3, if we bypass that check, we will hit the breakpoints inside the mod function again, because the program will call it again. So let's see if we'll hit it or not. If we don't hit it, then we didn't bypass that. Yeah, we hit it again, and now AX is E, which means already we are already after in the next, or in the second 4 character. So let's continue. F, continue. G, continue. H, and then continue, and we hit the breakpoint out. So now it's simple. Now we just need to get something that is divisible by 4. Let's do that. Let's keep them all A's, because of course if all the same, it will be divisible by 4. Yes, 0. So we just take that A. Okay, now if we run A, B, D, A. Let's see if we'll bypass that. Let's see A, Q, A. Okay, we hit the first one. Continue. We hit the return for the first time. Continue. Now we are at the next A. Continue. We hit the breakpoint for the second time. Now if we hit the breakpoint 3 again, then we already bypassed the second 4 character. Yes, we hit it, and now we are after that. So now the third 4 characters needs to be divisible by 5. So how do we know that? Because if we go to radar and see the main function, here it's pushing 5 this time. First it was pushing 3, and then 4, and then 4, and then 5, and then 4 again. Okay, so the last 4 character will be checked if they are divisible by 4. So let's get 1, 5 here. They are actually also divisible by 5, so let's keep that. So if we go here and do continue 4 times, we'll hit the 5 again. And then if we continued, because we entered A's already, we will go hit the 3 again. Yes, we do hit the 3. So now it will check if A, Q, A are divisible by 4, which is probably not true. So let's see what is hex for Q. Hex for Q is 51. Let's put 51 here. And see if it's divisible by 4 this time. Yes, it's divisible by 4. So go here and continue, and we get the flag. Yep, because we entered a valid key, and we can of course automate that to find all the possible valid keys. So this is the flag. Now we go out and then echo flag. This is 4, I guess. Is that 4? Yes. So this is the 4th flag. Now the 5th flag is a bit tricky, but it can just be done by debugger. So let's go, just close that. Just close that as no, that one is okay, clear. Okay. Yeah. Now let's download that channel 5 CB channel 5. Okay, more. Right. Yeah, I need to move that to 5 just for convenience. Okay, now it's saying sorry, computer's name is Kali is not correct. We know that it's checking for computer name, but we don't know actually how it gets it, so we need to open that in radar channel 5 and see how it actually gets it. Let's go for the main just to see the calls. Okay, now after it takes our input, it goes to check if our computer name is that one, iHack reverser and this one. So if it's not, it will go just fail and go here, okay, and say sorry, your computer name is blah blah blah. But how did it get it? At first it gets it with get name function. So let's go out and see what is this get name function. Get name function is that one. What it does is actually just skimming through, check something, and as you can see it looks complicated, but the point is here uname pushing -n pushing uname, and it says it is the command to check for computer name. Let's try that. Uname -n. Yes, it is a command to check for computer name, but we can do something. I did solve it like this. I bypass this check like this. Let's see that I wrote a script. Of course we can do it with debugging, but I wrote a script that will echo that thing and change it my environment variable path. Let's just uname to here, and let's get uname here, sh echo that thing, and then I will do that. I will export path equal my current working directory and path. Now if we run it again, it will not complain about our computer name is Kali. Okay, now computer name iHack server, iHack reverser. Now the OS version is that one, and it's saying it's not supported. So let's just get my nodes here, cp nodes to here, and just cat those because I'm going to need them. Yeah. Let's open in GDB. We opened that already. No, then okay, let's see in radar what is it checking again. Let's go out for, we can try to bypass every function like this, but other functions are calling actual files and are calling proc/version, which is not very easy to modify. So let's just see and do it with debugging. It's dynamically checking, and we will dynamically change. It's checking if it is 2.4.0. This is the OS version, and then it will check for CPU ID if it is Intel for laws. We don't care what this does right now or what this does already. So we'll go again here and open that in gdb. Yes. Now we need to break before the two checks. Okay, so let's just set this assembly flavor enter this assembly. Where checked. Get name is here. We already passed get name. Now it will compare and then it will jump if it's not right. Get OS here and then it will compare here. So we need to change this. We need to change this before going here. Okay. Right. This. Okay. So we need to break. We need to break here. Break here. Break that and break the other one. Get CPU ID, get name, get OS, and then get CPU ID. We need to break here as well. It's using the same variable 40C, so we'll change the same variable. Okay, now we just need to run and then we'll hit the first. Okay, there is a problem. Not sure what is that. Let's run it again. Let's break here. And let's break here. Okay, now let's run. Cannot access memory at that address. There's probably something wrong. Yeah. Yeah, I've been doing it wrong, I guess. I think we should break here. That's what I did, right? Oops. Then del 1, del 2, and break here. But why? Share 5. Okay, then let's just try again. Yes. Point here. Okay, now breakpoint before the get. We already did the get OS here. Get CPU ID here. Run. Oh, this is annoying. I'm not sure why it is calling a new, giving me a shell. try file share one. No, file share file. Okay, I just pause right now.